Hey everyone, how are you guys? I hope you guys are doing extremely well. Today is day 10 of hashtag 30 days of talking to camera challenge, and today the date is 29th of July 2023 and the day today is Saturday. So let's start. Today in this video I will be talking about some searching algorithms. Yesterday I have talked about sorting algorithms. I have discussed many sorting algorithms like merge sort, quick sort, bubble sort, insertion sort, counting sort, and all the sorting algorithms. And today in this video I will be talking about searching algorithms. So what are some of the searching algorithms? So some of the most famous searching algorithm is linear search algorithm, binary search algorithm, and jump search algorithm, and there one more is hashing algorithm. So first let us talk about linear search algorithm. So when do we use the linear search algorithm? Suppose you are given an array of n integers and we need to find a particular number, a particular element in that array. So in that case we would use linear search algorithm. How this algorithm works? For an example, suppose you have a books of let's say 100 pages and all the pages are at a random order. In the books that we regularly use, we have page number 1, then 2, then 3, then 4, then 5, then 6, and then so on till 100. Suppose if the book is of 100 pages, but what if the pages are in randomized order? Like first there will be page number 57, then 36, then 24, then 41, then 7, then 63, something like that in the randomized order. And if I tell you to find a particular page number, then what would you do? You can't search like that. You have to search one by one. You have to flip every page and see if the page number is which you have to search is there or not, and in that way you can search. Suppose if the page I told you is the first page of the book, you can search that in 1 second. I'm assuming that flipping one page is taking almost 1 second. So if you are searching for the first page, then it would take 1 second. So that's the best case. But what if I told you to search the 100 page? So it would take 100 seconds. In 100 pages of book, it would take 100 seconds. What if the book was of 99 pages or n pages? So in that case, the searching will take n time. So the time complexity of linear search algorithm is big of n. This is how linear search algorithm works. We will traverse through the entire array or traverse through the entire linked list, and then we will one by one check if the element there is a required element or not, and if the element is a required element, then that would be our answer, then that index would be our answer. So we have searched that index. So I hope linear search algorithm was clear. Next let's talk about jump search algorithm. Jump search algorithm is pretty much similar to linear search algorithm, but it takes slightly less time. So how does jump search work? In jump search algorithm, we would require two things. One is the array in which we have to search, and another is an integer k. So what we would do is, suppose we have array of 100 elements and the integer k is 3, and I have to search a number. And in jump search algorithm, we need to remember one more thing is that jump search only works for the sorted array. It doesn't work for unsorted array. If you have unsorted array, then in that case we need to apply linear search algorithm. So how we would search in the sorted array? We will use jump search algorithm. So what we would do is, first we will check the first number, and suppose the integer which is given is 2 is 3. So what we will do is we will jump 3 places and check if after jumping 3 places the number which we have got is greater than the target element or is smaller than the target element. If it is greater than a target element, then again we would skip 3 places and jump again 3 times. If it's still greater than a target element, then again we would jump. So in that way we would keep jumping, and suppose we came at the position which is equal to the target element, then we would return that index value. And if the target element is smaller than the element currently at which we are pointing, then we would apply linear search algorithm from its previous jump position and this jump position. So we would apply linear search algorithm. So what is the time complexity of this algorithm? The time complexity of this algorithm is also big of n, because it would take at least n times to find the array. I know it's slightly less than that, because we are like reducing it k times, we are skipping k elements each and every time. So the time complexity is improves a little bit, but it's not the fastest. So which is the fastest algorithm in case of sorted array? So in case of sorted array, the fastest algorithm is binary search algorithm. So how does binary search algorithm works? In binary search algorithm, we are given a sorted array. First we divide our array into half, and if the element is in the first half of the array, we would search only in the first half of the array, and if the element is in the second half of the array, then we would only search in the second half of the array. We don't need to traverse the whole array. Let me give you an example. Binary search algorithm is same as you flipping your books. Suppose I have a book of 100 pages and I want to open page number 63. So first I open page number 50, like that is the middle of the book, and now I clearly know that the page number 63 is after 50 from 100. It's between 50 and 100. It's not before 50. So now I will divide this part into two parts. So now I will be in page number 75. Like 50 plus 25 is 75 and 100 minus 25 is 75. So 75 is the middle of 50 and 100. Now what I will do is I will see if 63 is greater than 75 or 63 is less than 75. I know that 63 is less than 75. So now I would search, I will neglect all the elements after 75 because I know I can't get answer after 75. So now I will search from 50 till 75. Now I would again I would again divide it into 2. So now I would get 62.5. So I know that I will take if I am taking lower bound, then I will get 62. Now I know that it's between 62 and 75. So now likewise I would keep dividing and I would keep searching the element. In that way I can find the element. I can find the exact page number which we have to find. So this is the same case. This is the same intuition for binary search. This is how binary search works. Now let's understand what would be the time complexity of this algorithm. For the previous two algorithms which we have discussed take big of n time, but big of n time is a lot. The binary search takes slightly less time. So what is the time complexity of its algorithm? So we know that searching an algorithm takes big of 1 time, that is 1 second. Suppose 1 unit of time is equals to 1 second. So if the array is in the middle of the element, if the element is in the middle of the array, then we would find it in first time only. So it will be big of 1 time. So we know that at the iteration in which we find the element is constant, so it takes big of 1 time. Now each time I am dividing the array into 2, we are dividing at each iteration. We know that we are dividing it into 2. We are dividing it by 2. So suppose there are n elements, so first we divide it by 2, so n by 2. In the other iteration we again divide it by 2, so n by 4. In the next iteration we again divide it by 2, so n by 8. So here we can see a pattern: n by 2, then n by 2 to the power 2, then n by 2 to the power 1, then n by 2 to the power 2, then n by 2 to the power 3, then n by 2 to the power 4. Suppose we can find our answer in the kth iteration. So what would be the function for that? N by 2 to the power k. So what would be equals to n by 2 to the power a, because in kth iteration I found my element. So it would be n by 2 to the power k is equals to 1, because at n by 2 to the power kth iteration I am able to find my element, and finding an element take on big of 1 time. So n by 2 to the power k is equals to 1. So 2 to the power k would be equal to n. So what would be the value of k? The value of k would be log n base 2. So now we can understand that binary search takes log n base 2, and we also know that why binary search is the best searching algorithm when we are given a sorted array. Now you have understood why binary search is used, why binary search is the best sorting algorithm for sorted array. Yes, because it reduces very less time. I hope I was able to clearly explain the three searching algorithms, that is binary search, linear search and jump search. Now we come to our fourth searching algorithm. This is not actually a searching algorithm. This is called hashing. So what happens in hashing is hashing is a key value pair. So what we does is we count the number of frequencies of each element and we provide a hashing function. It could be anything like n mod 7 or n mod 10 or n mod 11, and we store its value accordingly. So hashing, what hashing does is we store a key and value pair. So if we want to search any value, we have the keys already. If we want to search any value, we would apply the hashing function and get the key, and we can straight away find its value. So applying the hashing function take big O of 1 time, and getting its value take big O of 1 time. So if we are using hashing, then in big O of 1 time, in constant time, we can get our answer. But here is a catch: in constant time we can get our answer, but applying all the elements in the hash function takes big O of n time, because we have to traverse each and every element one by one. But calculating calculating it in hash function take constant time, so it would take big of n time. Now why isn't it used? This isn't used. Binary search is used because hashing requires extra space. Yes, hashing requires extra space, that's why we don't prefer using hashing. I hope I was able to clear each and everything in searching algorithm. So thank you guys for this video. I hope I made myself clear. Thank you so much everyone for watching this video this far. So yeah, all the best for your journey, and wish me luck too, because I am trying each and every day to improve my communication skills and improve my English. I know I am still very bad in English and I am not able to explain things very well, but trust me, I explain things very well in Hindi, but just because English is my second language, I am not able to do this well. And I hope after 30 days or still whenever I continue this, my confidence would increase a little bit and my English speaking skills would also increase a little bit. So thank you everyone, keep supporting.